The impending digital shift, 85% of current internet infrastructure to become obsolete as AI agents dominate online interactions. Introduction. As we stand on the brink of a significant transformation in our digital landscape, the rise of artificial intelligence AI agents is projected to alter the internet infrastructure fundamentally. This shift is anticipated to render approximately 85% of the current systems obsolete. This report synthesizes insights from various sources emphasizing the implications of this transition and the urgent need for new frameworks to accommodate AI-driven interactions. The rise of AI agents. AI agents have been evolving rapidly, gaining the ability to perform complex tasks that were once exclusive to human users. These tasks include making phone calls, purchasing items online, and engaging in various forms of digital communication. As AI systems expand their capabilities, the demand for a robust and supportive infrastructure that can facilitate and regulate these agents is becoming increasingly critical. The concept of agent infrastructure. To address the challenges posed by the proliferation of AI agents, the concept of agent infrastructure has been introduced. This refers to the external technical systems and protocols designed to mediate interactions between AI agents and their environments. Such infrastructure is essential for ensuring accountability, shaping interactions, and mitigating harmful actions that may arise from agent behavior. Functions of agent infrastructure. The proposed agent infrastructure serves three main functions. 1. Attribution. This involves identifying and linking actions to specific agents and their users, ensuring that accountability is maintained. 2. Interaction shaping. This function guides how agents engage with users and each other, establishing protocols for interaction that align with societal norms and expectations. 3. Harm detection and remediation. This aspect focuses on identifying harmful activities executed by agents and providing mechanisms for addressing these issues promptly. These functions are crucial for creating a safe and accountable environment as AI agents become more prevalent in online interactions. Practical applications of agent infrastructure. The development of agent infrastructure can lead to numerous practical applications. For instance, enhancing user authentication systems could create a clearer link between agents and their users, ensuring that accountability is upheld. Additionally, establishing protocols that facilitate safer interactions in various digital environments will be a significant step towards addressing the challenges posed by AI agents. A theoretical framework for transformation. The anticipated transformation of Internet infrastructure shares similarities with past technological shifts, such as the introduction of HTTPS, which revolutionized web security. As AI agents become integral to online interactions, a reliable framework for their interactions will be essential. This framework must not only address technical aspects but also consider the societal and economic implications of widespread AI deployment. Implications for the future. The shift towards an AI-dominated internet landscape is not merely a technical evolution, it has profound implications for society as a whole. As AI agents take on more significant roles, the need for accountability and safety mechanisms becomes paramount. The transition is expected to redefine how we interact online, necessitating proactive measures to adapt existing frameworks. Timeline of events. Present to near future. The recognition of AI agents' evolving capabilities is gaining momentum, with discussions around the need for supporting infrastructure becoming increasingly relevant. 2025 onwards, as AI systems continue to advance, we can expect significant developments in infrastructure discussions, leading to the implementation of new protocols and systems designed explicitly for AI interactions. Conclusion. In conclusion, the impending digital shift driven by the rise of AI agents presents both opportunities and challenges. As we prepare for a future where AI systems dominate online interactions, the urgency for developing comprehensive agent infrastructure cannot be overstated. This evolution will not only redefine online interactions but also necessitate a re-evaluation of accountability, safety, and the very fabric of our digital experiences. Embracing this change with foresight and preparedness will be critical to navigating the complexities of an AI-driven world. The impending digital shift in internet infrastructure driven by AI agents presents several counterintuitive insights worth exploring. 1. Obsolescence of established systems. While technological advancements typically build upon existing frameworks, the projected obsolescence of 85% of current internet infrastructure suggests a radical departure from this norm. This indicates that the existing systems are not merely inadequate but fundamentally incompatible with the requirements of AI-driven environments. The idea that so much of the current infrastructure will become irrelevant challenges the common belief that evolution in technology is always incremental. 2. Accountability and automation. The rise of AI agents raises concerns about accountability and responsibility in automated actions. It is paradoxical that as machines take on more tasks, the need for accountability mechanisms becomes more pronounced. This contradicts the intuition that automation simplifies processes. In reality, it complicates the landscape by necessitating new frameworks to ensure that actions taken by AI agents can be traced back to human users, thus emphasizing the complexity of trust in automated systems. 3. Enhanced user interaction. Many view AI agents as potential replacements for human interaction, which could lead to isolation. However, the proposed agent infrastructure aims to enhance the quality of interactions between users and AI agents. This suggests a counterintuitive outcome where AI not only mediates but also enriches human experiences in digital environments. Rather than diminishing human roles, AI could redefine them in ways that improve interaction quality and safety. 4. Shift from user-centric to agent-centric models. Traditional internet models prioritize user-centric interactions where user needs dictate system design. The shift towards agent-centric infrastructures implies that the focus will increasingly be on how agents interact with each other and their environments, rather than solely on user experience. This counters the intuitive belief that user experience should remain the primary design principle in digital interactions. 5. Regulatory challenges. The introduction of AI agents necessitates a re-evaluation of existing legal and regulatory frameworks. It is counterintuitive to think that the introduction of a tool designed to streamline processes would complicate legal compliance. However, the complexity of interactions that AI agents are capable of necessitates a thorough examination of regulations that govern digital interactions, potentially leading to more stringent oversight rather than more relaxed rules. 6. Positive potential of risks. The focus on potential risks associated with AI agents often leads to a negative perception of their impact. However, the potential for these risks to drive innovation in safety protocols and accountability mechanisms is a positive counterintuitive aspect. As society grapples with the implications of AI, it may lead to the development of more robust systems that ultimately enhance digital safety and trust. 7. Interdependency of systems. The concept of agent infrastructure introduces a network of dependencies among various systems that will need to communicate and operate together. This is counterintuitive to the notion of isolated systems functioning independently. The interdependence highlights that creating effective AI agents will require collaboration across different sectors and technologies, which may lead to unforeseen synergies or challenges. 8. Complexity over simplicity. The common perception that technology simplifies tasks is challenged by the complexity introduced by AI agents and their required infrastructure. As the need for sophisticated interaction frameworks arises, it becomes clear that greater complexity in design and implementation may be necessary to achieve the desired simplicity in user experiences. These insights reveal a landscape where the future of internet infrastructure is not just about technological advancement but also about redefining relationships between users, agents, and the systems that support them. The counterintuitive nature of these transitions highlights the necessity for thoughtful consideration of the implications of AI integration into everyday digital interactions. The report detailing the impending digital shift highlights a critical juncture in Internet infrastructure due to the rising dominance of AI agents. While many might focus on the immediate implications of AI's capabilities and the need for updated infrastructure, several nuanced elements in the report deserve attention for their long-term significance. Overlooked elements and their significance. 1. Concept of agent infrastructure. The introduction of agent infrastructure is central to the report but may be overlooked as merely technical jargon. This concept is significant because it represents a paradigm shift in how digital interactions are structured. Unlike traditional infrastructure that merely supports data transmission, agent infrastructure is proactive, designed to shape interactions and ensure accountability. The implications of this shift are profound as it suggests a move towards a more regulated and controlled digital environment where AI agents operate, impacting everything from legal frameworks to user rights. 2. Functions of agent infrastructure. The report delineates three essential functions of agent infrastructure: attribution, interaction shaping, and harm detection/remediation. While readers might recognize the need for accountability, attribution, and safety, harm detection, the aspect of interaction shaping can be easily overlooked. This function is crucial as it determines how AI agents will engage with users and each other. The mechanisms put in place to guide these interactions could profoundly influence user experiences, trust in AI, and the broader ethical landscape of digital interactions. This shaping could include protocols for minimizing misinformation, ensuring respectful engagement, and enhancing user empowerment, which are pivotal in a future dominated by AI interactions. 3. Impact on accountability. The report emphasizes accountability but may not fully capture the complexity of how this will manifest in practice. As AI agents assume roles traditionally held by humans, the question of who is accountable for their actions becomes more pressing. The proposed infrastructure aims to create systems that can trace actions back to specific agents and their users. This is not just a technical necessity. It raises ethical and legal questions about liability, responsibility, and redress in cases of harm. The development of frameworks that can address these complexities will be critical in maintaining societal trust in AI technologies. 4. Potential use cases. The report mentions practical applications of agent infrastructure but might not delve deeply into how these use cases will affect various industries and everyday life. For instance, the enhancement of user authentication systems to create accountability could lead to significant changes in e-commerce, healthcare, and finance. The ability to trace actions back to users could deter malicious behavior and foster a safer online environment. These use cases represent a shift towards more transparent and secure digital transactions, which is essential as AI agents become more integrated into daily life. 5. Theoretical framework and historical context. While the report draws parallels between the current shift and past transformations such as the introduction of HTTPS, the historical context may not be fully appreciated. Understanding past transitions in Internet infrastructure can provide valuable insights into potential challenges and resistance that may arise. For instance, the adoption of HTTPS faced skepticism and slow uptake due to user inertia and the complexity of implementation. Recognizing these historical lessons can inform strategies for advocating for the new agent infrastructure, ensuring smoother transitions and broader acceptance. 6. Broader societal implications. The report primarily focuses on the technical and operational aspects of AI agents and the necessary infrastructure. However, the societal implications of this shift may be understated. As AI agents become more prevalent, they will influence social dynamics, economic structures, and even cultural norms. The potential for job displacement, changes in consumer behavior, and shifts in interpersonal communication due to AI mediation are significant areas of concern that warrant deeper exploration. Understanding these implications is crucial for policymakers, businesses, and society at large as they navigate the complexities of an AI-driven future. 7. Open questions and limitations. The report acknowledges open questions and limitations surrounding the implementation of agent infrastructure but may not emphasize their importance. Addressing these uncertainties is vital for building robust systems that can adapt to unforeseen challenges. For example, questions about scalability, interoperability with existing systems, and the ability to quickly respond to emerging threats are critical for ensuring that the proposed infrastructure can sustain a diverse array of AI agents and their interactions. Conclusion. The report presents a compelling vision of a future where AI agents dominate online interactions, necessitating a fundamental redesign of Internet infrastructure. While it touches on several key themes, the overlooked aspects, such as the profound implications of agent infrastructure, the complexities of accountability, and the broader societal impacts, are crucial for understanding the full scope of this digital shift. By recognizing and addressing these elements, stakeholders can better prepare for the transformative changes on the horizon, ensuring that the evolution of the digital landscape aligns with ethical standards, user rights, and societal values. The impending digital shift, characterized by the dominance of AI agents and the obsolescence of current Internet infrastructure, raises significant points for in-depth analysis and discussion. Here are the 4 most valuable points. 1. Emergence and capabilities of AI agents. The rise of AI agents is transforming online interactions, enabling them to perform complex tasks traditionally carried out by humans, such as making phone calls and purchasing items. This evolution not only highlights the technological advances in AI but also raises questions about the implications of delegating such responsibilities to non-human entities. The capabilities of AI agents necessitate new discussions about trust, responsibility, and the extent to which they should be integrated into everyday online activities. Analyzing the ethical considerations surrounding AI decision-making processes, the potential biases in their programming, and the implications for job displacement will be crucial as these agents become more prevalent. 2. Need for robust agent infrastructure. The introduction of agent infrastructure signifies a paradigm shift in how we conceptualize and manage interactions between AI agents and their environments. This infrastructure is essential for ensuring accountability and shaping interactions effectively. It serves as a framework that mediates the relationship between AI agents, users, and existing systems, including legal and economic structures. An in-depth analysis of what this infrastructure entails, its architecture, protocols, and standards, will be vital to understanding how it can be developed and implemented. Furthermore, exploring the challenges and limitations of establishing such infrastructure will offer insights into the feasibility of this transition. 3. Functions of agent infrastructure. The 3 main functions of agent infrastructure: attribution, interaction shaping, and harm detection and remediation, are critical for regulating AI agent activities. Attribution focuses on linking actions to specific agents, ensuring accountability, while interaction shaping guides how agents engage with users and peers, promoting positive outcomes. Harm detection and remediation aim to identify and address potentially harmful actions taken by agents. Each function presents unique challenges that warrant detailed exploration. For example, investigating how attribution can be effectively implemented in a decentralized and anonymized digital environment, or how interaction shaping can prevent manipulative behaviors by agents, are essential areas for discussion. 4. Transformative impacts and societal implications. The transition towards an AI-dominated internet will have profound implications for various sectors, including economy, governance, and social interaction. As AI agents take on more significant roles, there will be an urgent need to re-evaluate existing frameworks to ensure they accommodate this new reality responsibly. Analyzing the potential economic impacts, such as shifts in job markets and industries, as well as the societal implications, including privacy concerns and changes in user behavior, is crucial. Additionally, discussions around regulatory measures and ethical guidelines for AI deployment will be necessary to navigate the complexities of this transformation. These points collectively underscore the necessity for a comprehensive understanding of the impending digital shift, encouraging interdisciplinary discussions that incorporate technology, ethics, economics, and social sciences. Here are 3 famous historical cases that illustrate significant shifts in technology and infrastructure comparable to the predicted digital shift involving AI agents. 1. The Industrial Revolution, 18th to 19th century. The Industrial Revolution marked a monumental shift from agrarian economies to industrialized and urban societies. Innovations such as the steam engine, mechanized looms, and the development of factories transformed production processes and labor dynamics. Existing infrastructures such as rural farming methods and artisanal crafts became largely obsolete as mass production and mechanization took precedence. This shift not only changed the economic landscape but also had profound social implications, leading to urbanization, changes in labor laws, and the emergence of new social classes. The disruption caused by the Industrial Revolution parallels the anticipated obsolescence of current internet infrastructure as AI agents take over online interactions, necessitating new frameworks and systems to manage these changes. 2. The transition from dial-up to broadband internet, 1990s to early 2000s. The evolution from dial-up internet connections to broadband dramatically transformed how people accessed and interacted with the web. Dial-up connections were slow and limited, often tying up phone lines, while broadband technologies such as DSL and cable offered high-speed, always-on internet access. This transition rendered much of the previous internet infrastructure, including older communication technologies and software designed for dial-up, largely obsolete. The rapid adoption of broadband enabled the rise of new online services, streaming media, and e-commerce platforms, fundamentally changing user expectations and online behavior. Similarly, as AI agents become integral to online interactions, the current internet framework may need to adapt or be replaced to support these new technologies effectively. 3. The advent of the printing press, 15th century. The invention of the printing press by Johannes Gutenberg revolutionized the dissemination of information. Before its introduction, books were manually copied and were scarce and expensive, limiting access to knowledge. The printing press allowed for the mass production of texts, leading to increased literacy rates, the spread of new ideas, and significant cultural and religious shifts, including the Reformation. This technological advancement rendered the previous methods of book production obsolete and transformed societies by making information widely accessible. The rise of AI agents in digital interactions could similarly revolutionize the way information is processed and shared, necessitating new infrastructure to accommodate the complexities of AI-driven communications and interactions. These historical cases illustrate how technological advancements can lead to the obsolescence of existing systems and infrastructure, reshaping economies, societies, and interactions in profound ways. The future landscape of the Internet is on the brink of a transformative shift, primarily driven by the emergence of AI agents. As these intelligent systems become increasingly integrated into daily online interactions, it is projected that approximately 85% of current Internet infrastructure will be rendered obsolete. This summary outlines the anticipated changes, implications, and the necessary adaptations that will define the digital environment of the coming years. The rise of AI agents. AI agents are evolving rapidly, acquiring capabilities that allow them to perform complex tasks autonomously. This includes making phone calls, conducting online transactions, and managing user interactions across various platforms. As these agents become more prevalent, the existing Internet infrastructure, designed primarily for human users, will struggle to accommodate the unique needs and operational dynamics of AI. The concept of agent infrastructure. The transition necessitates the development of what is termed agent infrastructure. This refers to the technical systems and protocols that will be required to facilitate and manage the interactions between AI agents and their environments. It aims to ensure accountability, influence interactions, and mitigate potential risks associated with AI-driven activities. The agent infrastructure will serve three critical functions. 1. Attribution, establishing clear links between actions taken by AI agents and their human users or other actors. 2. Interaction shaping, guiding how agents engage with both users and each other, ensuring that interactions are meaningful and contextually appropriate. 3. Harm detection and remediation, identifying and addressing harmful actions undertaken by agents, fostering a safer digital environment. Implications for Internet infrastructure. As the demand for AI-driven interactions increases, the existing Internet architecture, largely based on human-centric models, will need to be overhauled. Key implications include obsolescence of current systems. Much of the current infrastructure will be unable to support the complexities of AI interactions, necessitating innovative solutions that are adaptable and scalable. New protocols and standards, just as HTTPS revolutionized web security. New protocols for AI interactions will need to be developed to ensure secure and reliable exchanges. Economic and social impact. Industries will face disruptions as AI agents reshape how services are delivered and consumed, potentially leading to shifts in job markets and economic models. Future use cases and applications. The potential applications of AI agents are vast and varied. Some notable use cases include enhanced user authentication, developing systems that hold users accountable for the actions of their AI agents, thereby addressing issues of liability and trust. Safer digital interactions, creating protocols that enable safer interactions between users and AI as well as among AI agents themselves to prevent malicious activities. Automation of online services, streamlining processes in e-commerce, customer service, and information retrieval, thereby enhancing efficiency and user experience. Timeline for transition. The transition towards an AI-dominated Internet landscape is expected to unfold gradually. Present to 2025, initial recognition of AI agents' capabilities is growing, with increasing discussions around the necessity for supportive infrastructure. 2025 onwards, as AI systems evolve, the implementation of new protocols and systems tailored for AI interactions is anticipated. This phase will likely see collaborative efforts from tech companies, regulatory bodies, and research institutions to establish the necessary frameworks. Conclusion. The impending digital shift towards AI agents is set to redefine online interactions fundamentally. As we move forward, it is crucial to proactively develop comprehensive agent infrastructure that addresses the challenges of accountability, interaction dynamics, and potential risks associated with AI deployment. The future will require a collaborative approach to reshape the Internet, ensuring that it remains a safe, efficient, and accessible space for both human users and AI agents alike. The success of this transition will depend on our ability to adapt existing frameworks and innovate new ones that cater to the unique demands of an AI-driven world.